Welcome to day 6 of my AVR Advent Calendar. In this series of videos you will learn in 24 days how to program the AVR 8-bit microcontroller. So let's take a look what's in paper bag number 6. Okay, so here we have a small push button and a 10 kilo ohm resistor, because in today's video I will show you how to control this button or how to read in the state of this button by using the I/O ports of the Mega 88PA microcontroller. But first let's take a look at the circuit. So last time we already connected an LED to our Mega microcontroller, and this time I will add a button. And the goal for this video is when I press the button and the LED is off, it will turn on, and if I press the button again and the LED is on, it will be turned off. So this is the plan for this video. And you see here I've added this LED here to port B pin 0, and to port D pin 7 I will add this button here. So when I press the button there will be a high level on this pin, and if I don't press the button, so I don't have a floating pin here, I have this pull down resistor to ground, so when the button is not pressed, here I will have a ground voltage applied here, or a voltage of 0 volts applied here. Okay, so now please give me a second so I can build this circuit on my breadboard here, and then I will come back. Okay, so now you can see I've added the button here, and now let's write the program. Therefore I will cd into my AVR Advanced Calendars folder, and here I have created a folder called 6button, but this folder is empty right now, so let's copy everything from the LED example into this folder here, and let's run a clean first. Okay, so now we have our main program for the microcontroller and a makefile to build it, and here in the makefile this traffic light I will switch to the name of the target to button, so our compiled program should be button.elf or button.hex. Okay, and now let's open up the main folder here. Okay, let me delete a little bit here, so I don't need these lines here, so let me delete them. Okay, and one thing, I don't need these two defines here, and instead of red I will use LED here, and I will add a new define for the button, and the button is connected to port D pin 7. Okay, and here the init I only have to init the LEDs pin at port B0, and now in theory if I want to set the button to an input, I have to write a 0 to it, and I will do this by ANDing the data direction register of port D with 1 shifted by PD7. But normally I don't have to do this, because the default value of DDR D is already 0, but I will leave this here just for information. Set PD7 to input. Okay, now let's take a quick look at the datasheet of the AVR Mega 88 microcontroller, because here we can see for reading the current state of a button we have this port input pin register here. So here, if for example this pin B5 has a 1 written to it, we know we have a high level at this pin, and if a 0 is written to it, we know it has a 0 volt level at this pin, and this way we can find out the state of the pin. Okay, so what I will do now is if port in D and 1 shifted by button is bigger than 0, then we know the button was pressed. And what I will add here is I will add a delay of 50 milliseconds, and this is for debouncing. So if you are pressing such a physical button once, in reality it will bounce a little bit, so the microcontroller can see multiple changes in the level going up and down all the time. And to prevent this, I will add this sleep here to debounce the button. Maybe I will do a video about debouncing later. And now I will check the state. So in case the state is 0, I will write to port B, and I will use this XOR function to set the LED if it's not set, or to reset the LED if it's set. Okay. And I will set state to 1. And the reason why I'm doing this is so when I hold the button pressed, I don't want it to switch the state all the time. So if I press the button once and hold it, the LED will only turn on or off, and when I release it and I press it again, the state will change again. Okay? But in case the button or the pin here is not pressed, I will set state back to 0, so in the next time I press the button, it will jump into this states here again. Okay, so now let me try to compile this program. This works, and we now have our button.txt file, and now I will use AVR Dude to flash the program. So button hex, I have to give it my password. Okay, and now when I press the button, the LED goes on. If I press the button again, the LED goes off, and I hold the button pressed again and nothing changed here, and now if I press it again, the LED is on again. Okay, and before I end this video, I want to mention one more thing. I've told you we need this resistor here, so when the button is not pressed, we have a defined level here at the pin, and the input is not floating. But you can, you don't have to use this external pull-up, because the microcontroller also has internal pull-ups. And for using these internal pull-ups, all you have to do is you would have to change the program a little bit. So set internal pull-up, and to set it you have to write to port D, to the data register of port D, and you have to set the 7th bit here. And by this way you add a pull-up resistor, but one thing you have to change if you want to use it this way is, instead of connecting the pin to 5 volt when the button is pressed, you have to connect the pin to ground when the button is pressed. Okay, cool. So that's it for today. I hope you have enjoyed the video. Thanks for watching, and I hope I will see you tomorrow.